Hello friends, and this is lesson 10 part 1. Here we are going to talk about the basics of probabilities. So we have to know what is probability, then some basic terminologies we are going to talk, then compound events and basic rules here, then binary classifier and confusion matrix. So let's talk about what is probability. So probability here is nothing but the probability of event represents the frequency or the chance that the event will happen. So this is called the probability. The chance or the frequency that event will happen is called the probability. So actually, why do we need probability here in data science? Because this probability is helping us for building the models and evaluating the models, and models are used to test and also predict the result or unseen data. So for that we need the probability here. So it is nothing but a branch of mathematics, so we need that. And probability, there is something called relative frequency. So what is relative frequency? Relative frequency, how often an event occurs divided by total number of observations. How often the event occurs. So that is called relative frequency. In here we said that the probability of an event is nothing but the frequency or chance that the event will happen. So this is the classical definition for the probability. P of E, probability of E means the event is equal to favorable number of outcome of the event divided by total number of outcome. So this is the classical definition for the probability. It means, for example, if you are tossing a coin, so there are two probabilities, either you will getting head or tail. So if you want the head, so that is nothing but your favorable outcome. So what is the total number of outcomes? So the total number of outcome is equal to 2, because we have head and tail, then that head and tail both becomes 2, the total number of that. So if you want head, the head is 1 head divided by 2, so that is 1 by 2, the chance is 1 by 2 is equal to 0.5 or 50% we can say the chance of getting the head. So that is called the probability. Let's see some terminologies here. The first thing here we have to know is the experiment, or it is also called the procedure. So what is experiment? Experiment is nothing but the action which gives an outcome. Any action that gives an outcome is called the experiment. For example, tossing the coin, what we say, this is nothing but the experiment because it provides the outcome, either head or tail. So then we have something called a random experiment. Actually, this experiment is divided into two types. We have deterministic and non-deterministic. In non-deterministic, then we have random experiment. So random experiment is so the experiment for which the outcome cannot be predicted with certainty. This is called the random. So it means we cannot predict the outcome or the output. We cannot predict what will be the outcome. For example, if you're tossing the coin or flipping the coin, you cannot say what is the outcome there. But possibilities are there, we will get head or tail, that is something different, but certainly you cannot say that we will get head. That is called a random experiment. So you cannot predict the outcome with certainty. This is the example like tossing a coin or throwing a die. So you cannot say you will get the 5 for die or 6 or 3. The chance is there, but surely you cannot say that we can get the result or the outcome. So that is why it's called random experiment. Then something we need to know is sample space. So what is sample space, friends? Sample space is nothing but the set of all possible outcomes. The set of all possible outcomes in a random experiment is called sample space. For example, see example here, tossing a coin, we have two outcomes here. So this set is called the sample space of a coin or in a coin. Or whenever we are throwing a die, so there the outcome, total number of outcome or possible outcome is nothing but 1, 2, 3, 4, 5, 6. So this is called the sample space. In a coin, this is called the sample space. Or for example, if the question is like coin tossed 3 times, if coin is tossed 3 times, so it is not this, this is not the the sample space, because it is 3 times. So this is the sample space for a coin to be tossed 3 times. This is the chance of you will getting 3 heads or 3 tails, or for example 2 heads 1 tail, like that. So the next thing we are going to talk about is the event, because we talked about event every time, event. So now it is important to know what is event itself. So event is a subset of a sample space. So we said sample space is all possible outcomes of a regular experiments. For example, this is called the sample space, or this is called the sample space. But what do you think about getting a subset of this? So subset of this is nothing but an event. For example, subset of this is either head or tail, or for example both you can say. So that is called the event. For example, here this is the example of throwing a die. So throwing a die, this is the sample space, and this is called the event if you are getting 3, or for example 1, 3 or 5, or maybe 1 either, or 2 or 3 or 5, any of them. So that is called the event. The next thing is something called compound events. So the name itself indicates compound events means what? If you are combining 2 or more simple events, so that is called the compound events. For example, if we have event A and event B, so we are combining them, so that is called compound events. The probability for that is nothing but, for example, if we have A and B, so this can be represented by this probability of A intersects B, and that is equal to probability of A and B, the intersection point, because the common part or the common elements, or we can say the events we want here. But if you go to the probability of either A or B, so here it means we take the union of both. The union of both means the common elements, including the elements in A, in B, but not repeated elements. So that can be indicated by probability of A or B. So this is called compound probabilities. Now let's see some rules here we have. The first rule is called the addition rules or union of events. So this is called the union of events or addition rules, we can say. For example, for any 2 events A and B, so probability of A union B is equal to probability of A plus probability of B minus their intersection. So what does it mean? Let's see an example, then you can better understand. For example, if a die is thrown, find the probability of getting either an even or an odd, even or a number greater than 4. So here we have two events, because one event is here, like it says an even number or a number greater than 4. So for that we have the probability of A union B is equal to probability of A plus probability of B minus their intersection. This is an example. So it is said the probability of even numbers or a greater number than 4. So if A represents the first event and B represents the second event, so in first event we have we have even number. Okay, even number. So 4, 2 and 6, these are the even numbers. But the part says numbers greater than 4, so B is the second event, and in that we have 5 and 6. These two are the numbers greater than 4. Now let's see the probability of getting even numbers. So how many even numbers we have? We have 3 even numbers. So 3 divided by, according to the definition of that, favorable numbers divided by total number of outcomes. So favorable numbers we have, how many favorable numbers we have? 3 divided by 6. So this is the probability of event event A, and let's go and see the probability of event B. So that is equal to 2 by 6, because we have 2 elements and total number of outcomes we have 6. So 2 divided by 6. Now what is the intersection point? The intersection point says, so if you are taking the common, what is common between these two sets? So set A and set B, or event A and B, so the common element is 6. So 6 is a single element, and that is 1 by 6. Now you put it in this formula, then we get 3 by 6 plus 2 by 6 minus 1 by 6. So the result becomes 4 by 6, and that is equal to 2 by 3. Now we have the intersection rule, or we have multiplication. So in multiplication, friends, now see here, the multiplication rule is used to calculate the probability of events. So that is called the intersection. See, the probability of A intersects B is equal to probability of A and probability of B, and that can be equal to probability of A into probability of B given A. For example, here again we are taking the example of throwing the die. So what is the probability that if we randomly select the number 3 and the number 5 without replacement? So okay, if A is first event, so what is its probability? Probability of that is equal to 1 by 6, because in this sample space we have only 1, 3, so 3 divided by, not 3 divided, it's number of occurrence, so it is 1 divided by 6. Then the second event is B, and that is equal to 1 by 5. 5 is only 1 times repeated here, but 1 by 5. Why by 5? It should be by 6, because here it has a condition, it says without replacement. So without replacement means, so 3 is not there, because 3 is already taken, 3 is not there. So if 3 is not there, so after that we have only 5 elements. So in 5 elements, the possibility of that is equal to 1 by 5. Now according to this formula, now you put it here and you will get the result. Probability of A and B is equal to probability of A into probability of B given A, that is equal to 1 by 6 into 1 by 5. So if you are multiplying and dividing, the result will be 0.033. Next we have mutual exclusive events, or exclusive events. So here we say that two events are mutually exclusive if they cannot occur simultaneously. The same time they cannot occur. So this means their intersection point is equal to null or empty. So just that the intersection of the events is an empty set. For example, here probability of A union B is equal to probability of A or B, and that is equal to probability of A plus probability of B. If this pot is equal to 0 because it is empty, so it is empty means 0, so we will get this one probability of A plus probability of B. Again, let's see the example of throwing a die. So throwing a die and the probability of getting either an even number or an odd number. So this is the sample space, and this is event A and this is event B. So these are even numbers and these are odd numbers. If evens happen, so we cannot get the odd numbers. If odd numbers happen, so we cannot get the even numbers. So that is called mutual exclusive events, that both cannot happen simultaneously. Now let's talk about dependent and independent events. So what do you mean by that? Two events A and B are called dependent if knowing something about either A or B, about A, it gives information about the second one, B. Or for example, if you know about B, so it provides you the information about A, vice versa. If they are not providing, for example, if you are getting A, it is not giving you information about B, or if you are getting B, it is not providing you information about A, so they are called independent. If it is providing, so we call it as dependent events. So here is probability of B given A, and that is equal to, according to the previous example, so it is probability of B and probability of A given B, and that is equal to probability of A. For example, now see here friends, if two events are independent in the following, this is the equation we can put. Example, let's see the example, then you can better understand. Tossing a coin twice, getting first time the head. If you are tossing a coin twice and first time you got the head, you know that it is not giving you the information about the second toss, whether you will be getting head or tail. So here it is not providing any information about the second toss. So if it is the case, so it is called independent. But friends, one information it is providing, that two tails we cannot get, because already we have one head. The toss is the coin is already tossed once, so we already have a head. So that in the second chance it will be either a head that becomes two heads or a tail, but we cannot get two tails. If this is the pot, so they are called dependent, because it provides the information. We cannot get two tails because already we have one head. It may be either one head that becomes two heads, or it may be a tail or only single tail. This is the second part, or this is called the dependent, but here this part is showing us independent. Exhaustive events we have then. Two or more events are said to be exhaustive if their union is a sample space. For example, event A, B and C, three events we have. If we take their union, so it is providing as a sample space of the die. So this is called exhaustive events. And the last one here we have complementary events. So what is complementary events? In complementary events, friends, the complement of event A is opposite or negation of A. It means, for example, if A is the event where someone has cancer, so this is its complement, means that someone has no cancer. That is the event. For example, true and false. That is called, if this is true, the complement of that will be false. For example, here it is indicated like this: P of complement of A is equal to 1 minus, minus probability of A. For example, by throwing a die, so this is the sample space. If this is the event, so this is its complement, because if these elements are subtracted from this sample space, the remaining things what we are getting is 4, 5 and 6, and it can be simply indicated by 1 or getting 1 minus probability of A. This is also the formula, or manually you can subtract also that. So now let's see here some examples here. Probability, we define that probability is nothing but represents the frequency or chance of an event that will happen. So the universe consists of all possible outcomes, and any subset of that outcome is an event. So we will use probability theory to build and evaluate the model, as I mentioned before. So this is required in data science for building and evaluating the models. So that is why we need them. So this is the classical definition, friends. We said probability of A is equal to favorable number of outcomes of E divided by total number of outcomes. Now let's have an example here. So let's consider a set of 100 people who showed for an experiment in which a new test for coronavirus is conducted. So here in this we have here a total number of people. Here we have 100, and in that A represents 25, means these 25 people, they claim that they have coronavirus. But here in this set, here we have B, and 30 people, they claim that they don't have coronavirus. But here if we go to the third, here we are taking the union of both. So the union of both, if it is 20, the union of both 20, so how many is left here? 10 is left here and 5 is left here. So now if you want to know the probability of these, only this A set based on the parent set 100, so what is the probability of that? Let's see, friends, here. So according to the figure, A represents those people who claim they have coronavirus, B represents the set of those people they claim that they don't have coronavirus, and AB is nothing but the intersection point. So that is the people who have virus and had positive test outcome, AB, this one. So the white space here, the white total other, refers to the peoples or the people with no claim. Now relative frequency, we said how often an event occurs divided by total number of observations. So if you are finding the probability of event A, this is event A, so that is equal to 25, and total number of people, here we have 100, so 25 divided by 100, so that becomes, this is the result for that, 0.25%, or we can say 25%. And what about this set? The second event B says 30 people among 100, so 30 divided by 100, so that is equal to 0.3. Now we have the people who have virus and had a negative test outcome. See, friends, these people claim they have virus, but whenever we conducted the test, so among 25 we have 5 people, they claim they had virus but they don't have. The test indicates that they don't have. So 5 divided by 25, these are the people who have virus and had negative test. The test is negative and they claim that they have. So this is the percentage of that, 0.2. And now let's go to the second part, people with no virus and positive outcomes. So these people B, they claim they don't have virus, but after the test is conducted, how many? Okay, only 10 of them they are negative. The result came negative. 20 of them the result came positive. So for that, 20 divided by 30, because among 30 they claim they don't have virus, but 20 of them are infected. What about this one? People have virus and had positive test. So people, they claim they have virus, and after conducting the test, 20 of them had really positive result and only 5 had negative result. So that is why 20 divided by 25, and the remaining there we have 10. The people with no virus, they claim they don't have virus, and the result also shows that they don't have virus. So we are getting, these are the percentages and these are the probabilities what we are getting. So I hope you understood this much, friends. We are going to talk the remaining part, because this one is a little bit a lengthy part, so that we are going to talk in the second part of lesson 10. I hope you understood this much.